So I'm Yusuke Kuwayama. As I mentioned during introductions yesterday, I'm a fellow at Resources for the Future. I'm a natural resource economist by training, and I'm really happy to be here and appreciative of Andrew and Carrie for inviting me to give a presentation. I think the reason why a presentation from me might be helpful for the purposes of this workshop is to provide an economist perspective on how remotely sensed information, generally speaking, can be useful for economic research. Okay, and let me start with a few caveats about that. So first is that for successful socio-environmental systems research, we need much more than economics on the social science side, for sure. And some of the other social science disciplines are represented in this room, and please, as we get into discussions, we should make sure that those perspectives are represented. And certainly, I won't try to provide that perspective in my presentation because it is outside my area of expertise, and I certainly didn't have enough time for this presentation to be comprehensive about trying to understand what those perspectives are. So in some senses, it is a fairly narrow way of thinking about social science research using remotely sensed data, but I'll try to put things in context as much as possible. How many of you here have worked with an economist directly to the extent that you've sort of gotten to know them a bit and sort of what they do? Okay. So, all right, so there's a bit of heterogeneity here. And so there might be a range of, some of you may already know everything that I'm going to say. And for some of you, it might be a little new. So for those of you who know some of this already, appreciate your patience. But for audiences that are less familiar with economics, I like to kind of go to the top field journal in environmental economics. So this would be the subdiscipline within economics that addresses environmental policy issues, and put up some titles of the most downloaded articles in recent months. And just to show that, economists don't just work on stock markets and forecasting economic growth and questions like that where, that's how economists typically appear in the news, right? We looked at the effectiveness of banning plastic bags in different cities, the effect of air pollution on crime, groundwater depletion in lower middle income country contexts, and deforestation as well. So we cover, by economic outcomes, we refer to any sort of outcome that relates to a decision made by individuals. And so when it comes to environmental and natural resource questions, it could appear in many different domains. So we can think broadly about what it is that economists are interested in research that might involve remotely sensed data. So let me talk a little bit about methodology and kind of the key methodological tools that approaches that economists use when thinking about natural science data and using it within SES context. So this actually applies generally to natural systems data, not necessarily remotely sensed data, but we can provide lots of examples from remote sensing as well. So a lot of what economists do is called econometrics, which is really just statistical approaches that are tailored toward analysis of decisions made by individuals and firms. And your typical regression equation, might take linear forms, nonlinear forms, all kinds of fancy things you can add to these statistical approaches to control for different attributes of the data, but here's a very simple representation. We're just trying to understand what the effect on this variable y, which might have a spatial component, so this is y measured for individual I or parcel I in time period t, how that relates to some intercept, plus the role of some sort of other variable, right, x. Again, in its most simplistic form, it could be at the same spatial and temporal scale. And this, we can think of this as sort of the explanatory variable of interest when trying to understand what determines y, right? And then we might have a vector of other variables that serve as controls. So these are things that may also help determine why in a statistical sense, but it's sort of not your particular set of variables of interest. And then an error term. Okay, so you estimate this. In socio-environmental systems research, with this kind of estimation might involve an X or an Y that are related to a human system or a natural system. They could be both human, they could be both natural, right? Well, actually, at least one of them has to be human for it to be an interesting SCS kind of feedback or linkage type regression. And then X or Y can be remotely sensed or not, right? So the outcome that we were observing, land use, might be remotely sensed, or the driver of that might also be remotely sensed. So again, the universe of possibilities and how remotely sensed data might enter an econometric analysis. Ideally, opinions differ on this across economists, but ideally the reason why you're trying to understand these statistical relationships is driven by some sort of economic theory, right? There's a reason why you think this relationship would be observed in data. And it could be something as simple as, firms choose to output levels so as to maximize profits. And so you want to empirically look at the relationship between output and profit over time. Some more SCS type examples, right? What is the impact of temperature on irrigated acreage? You could imagine that, so irrigated acreage being sort of the outcome of a human choice, right? And you could think of both of these as potentially being remotely sensed or built on top of remotely sensed data. What's the relationship between access to roads and deforestation? For example, again, potentially remotely sensed or not, right? So yeah, basically statistical approaches to look at relationships between two variables is something that we do a lot in economics. And in the SCS context, so this is taken directly off of the NSF CNH solicitation, right? This is kind of your basic coupled human natural systems diagram. Those of you who've been involved in NSF CNH proposals probably have recurring nightmares about this. But these relationships between X and Y, where one is on the human side and the other is on the natural side, you're sort of trying to estimate that relationship empirically, right? The coupling between some characteristic on the human side to some characteristic on the natural side, and sort of the direction of the causality, right? The cause and effect might be in one direction or the other. Another, a related set of regressions that a lot of economists run is tied to a type of study called impact evaluation. So this is a little more nuanced than just looking at a relationship between one variable X and another variable Y. It's the role of a certain person or firm or parcel being subject to an intervention of some sort, it being enrolled in a program, it being subject to a certain policy, on an outcome tied to that individual parcel or firm Y, relative to a control individual or control firm or control parcel that was not subject to that intervention. Okay, so an experiment in some sense. We often refer to the key variable of interest in these impact evaluation regressions as whether this particular unit was treated or not in this particular period of time, right? So was it subject to the policy or not? If it wasn't, it's that value of that variable is 0. If it was subject to that policy, the value of that variable is 1. And so we're trying to understand if that variable goes from 0 to 1, what's that impact on Y, right? And so, for example, the treatment here might be enrollment of a farm in the USDA's Conservation Reserve Program, right? And Y might be crop acreage. Does enrollment in the program actually reduce crop acres? Which, given existing literature, is actually not that straightforward of a question. There's some evidence that farmers, while they may reduce crop acreage with CRP land, they might increase acreage in non-CRP land, right? So that's why this kind of question is interesting. And then, did this particular ag extension program, right? If this particular landowner was treated by that program, so to speak, then on that land do we see less invasive species spread, for example? Okay, so there's, the reason why economists are very interested in impact evaluation is that it ties directly to policies, programs, interventions, these things that are designed to influence human decision making. And we want to see whether the design of those interventions achieve their intended outcomes. And so, again, going back to this diagram, right, the impact evaluation might just be purely within the human system, right? So it might be this, enrollment in CRP, which is sort of like an institutional human system attribute, right? Does it influence crop acreage? That's a human decision, right? So that would sort of be internal to the human system in terms of the relationship that's being addressed, but then you could potentially have a variable that goes beyond acreage to some biodiversity outcome or some natural system variable that you're ultimately interested in, right? So the impact evaluation tool could be used sort of in these two domains of the CNH diagram. Okay. A little bit more about econometrics. So economists, for better or for worse, are really concerned about causality, and that statistical correlations between X and Y in these regressions are causal in the sense that they aren't just observed correlations, that there is some sort of mechanical, logical reason why changes in X are affecting Y. Okay? And the reason why a lot of economists are concerned about this is that it leads to information that is probably more effective for policy design. Okay? So let me just give you an example of where a correlation may not be causal. So in the gun control debate, right, there are some people who argue that violent video games is the reason why there is a lot of gun crime in this country. And so people have studied that. They've looked at households where children have played lots of violent video games and see whether those children later in life are involved in gun-related crimes, right? And some of these studies find that there is a statistically significant relationship between those two. But there are many other potential determinants of whether an individual ultimately is involved in gun-related crimes or not, right? And it might be, access to government services. It might be parental involvement, more broadly speaking, within when the child was raised, and so on, right? There are all these other things that might matter other than whether video games were part of their upbringing or not. And it's important to know which of those things is actually causing or is the most important factor in determining participation in gun crime, right? If you only look at video games, that might be correlated with some of these other things, such as other dimensions of parental involvement and nurturing and so on. But drawing the conclusion that banning violent video games is going to reduce gun crime is probably not the right conclusion there. So you could see some analogous issues of taking correlations as being causal and developing policies behind that to be problematic in a natural resource management setting as well. Let me just do a time check. Okay. So what are some issues that are attributes of the data that might lead to some threats to causal identification, that you might start seeing correlations that aren't actual causal processes within human systems? And one is sample selection. So the data on the people or the firms that you have come from a selected sample of individuals and firms that aren't representative of the broader population. So if your goal is to draw conclusions about the broad population, you might not be getting the right magnitude or direction of the relationship that you're trying to estimate. Another one, this comes in many forms, endogeneity. So basically, it's actually in many forms, it's this exact issue of observing things that in your data they're correlated with things that you don't observe, but it's really those things that you don't observe that are driving the outcome of interest. Okay. So, a couple of examples. So going back to the CRP example, right? CRP is a program where the landowner needs to apply to participate. So are the landowners who apply a good random representation of the population of landowners? Probably not. They're probably the ones that have some sort of aspect of their agricultural practice or their land that makes it very costless for them to enroll in the program, right? What they give up in terms of agricultural production is probably small relative to landowners who are not likely to apply. And so if you look at the relationship between conservation and enrollment in the program, from this sample you might get a bigger sensitivity to enrollment in the program than the rest of the population, so that has implications for whether if you scale up the program you're actually going to see as much take-up and land conserved. Another one is spatially correlated human behavior. So a good example here is there's this kind of common property resource theory, right, in social science where if there's a scarce common property resource with limited property rights and agents are extracting that resource, then you get this, tragedy of the commons where the resource is over-extracted and there's this kind of competitive race to the bottom. Some things that economists have tried to do is, in order to see whether that kind of behavior is observed in data associated with resource extraction, is to look at rates of resource extraction and try to see if those users that are closer to each other, for example, so are more likely to be sharing that common property resource, have similar extraction rates compared to those that are farther away. Because if they have similar extraction rates, that's sort of evidence that they're competing against each other, right? And so there are studies that have done this in the groundwater pumping context, for example, and find some results that there's this correlation between kind of the number of neighbors and the rate at which you extract groundwater. Okay? But the rate at which groundwater is extracted by an irrigator might depend on a lot of other things, right? And it might just be that the yield in the aquifer in that particular area is really good. So that's why you observe all of this groundwater pumping, right? So it's the yield, the aquifer yield that is spatially correlated that's driving the spatially correlated behavior, and it's not necessarily the competitive aspect of common property resource extraction that's leading to that higher extraction rate, right? So again, it all has to do with what exactly are you observing in your data, and is it really what's driving the outcome of interest? Okay. So the other bucket of methodological approaches I thought would be relevant for the kinds of data we're talking about here is bioeconomic and hydroeconomic modeling. And I think the easiest way to describe this to a broad audience is it's sort of a process-based approach to modeling socio-environmental systems, including both the natural system side and the human system side, right? And so an example of sort of a process-based model for human behavior in these kinds of models is there's some function that measures net benefits, right? For a firm, this might be profit. For an individual, this might be some measure of what economists call utility, right? And that is going to be a function of some human control variable. So this is a variable that this individual who's experiencing net benefits has control over, can choose. But then this is some sort of environmental problem where there's a natural state variable, right? A state variable tied to the natural system that also influences the net benefits experienced by the individual, and then some parameters that relate these two variables to the net benefits. Okay? So you sort of define a function, and if you kind of parameterize this, you try to make sure that that parameterization is consistent with some basic axioms of human behavior, for example. For example, if you prefer an apple to an orange and you prefer an orange to banana, then you prefer an apple to a banana, right? I mean, these are the kinds of basic axioms of human behavior that ultimately go into mathematical representations of net benefits. And then you might have a state equation, particularly in a dynamic setting where the evolution of the natural state variable that influences net benefits also is a function of the choice that the human system entity makes, right? So this could be resource extraction, for example, and this could be resource quantity. It might be a dynamic system where the rate of change of the state variable depends on the value of the state variable itself, and then again some parameters, right? And so basically our point here is that you could have these less kind of statistical approaches to modeling these integrated socio-environmental systems, and the role of the remotely sensed data would basically be to estimate these parameters, right, before you run the model. Okay, now that's sort of a methodological discussion, so let me go through some examples. And all these examples are actually sort of in the first set of methodologies, the econometric approaches. So this is a paper that we published last year that looks at the impacts of oil and gas development on agricultural land use. And we define agricultural land use by the type of crop that is planted in a given year. And so what we did was we used Cropscape, which relative to Neon might be sort of a dinosaur-like product at this point, but you know, it was easy to handle for us. But yeah, Cropscape on a 30 by 30 meter resolution, I think, tells us what kinds of planted crops are, what type of crop is planted. And then we merge that with the timing and location of new oil and gas wells in North Dakota. Okay? And conveniently, the scale of the crop data was consistent with the footprint of an oil and gas well, which is around 100 meters. This study was motivated by an article that came out in Science, which sort of did something like this, except used data from one county in Texas and then extrapolated to the whole country and estimated a 6% loss in wheat production in the United States. And you know, as economists, we read that and it's like, well, it's not, the extrapolation is an issue, but also it's not like the wells go in and then that land is changed forever. If we understand how oil and gas wells work in terms of their life cycle, there's a little more nuance to it. And so in addition to looking at impacts on agricultural land use in the same year that the oil and gas well is drilled, we looked at years before and after. Oh, and this is where the benefit of repeat observations tied to Cropscape was really helpful. We could see what was planted in years before and after a well. And if you trace that out, we see that there's a little more nuance to it. So for things like spring wheat, in the year of well drilling, we do see a dip in the proportion of cells covered by spring wheat near the well. And that dip sort of persists for at least 3 years. But for durum wheat, we see, again, this drop, but some sort of recovery. Okay, and these wells typically get drilled. The drilling process is pretty disruptive, and then a lot of these wells during this time period were fracked as well, and so that requires a lot of disturbance. But once the well is producing, then some reclamation can take place around the well, and that's what we observe in this for some crops. We think that the difference between spring and durum wheat has to do with the riskiness associated with disease for the two crops, as well as their profitability in the market. Okay. This is a study related to remotely sensed air quality, particulate matter specifically. And the basic question that this study tried to address is the Clean Air Act has national ambient air quality standards tied to particulate matter. I think it's 15 micrograms per cubic meter or something like that. And counties that achieve that standard are placed in an attainment status for the policy, for the Clean Air Act. And counties that have concentrations above that are in non-attainment. If you're a county that is placed in non-attainment, then you have to place additional controls on air pollution in your county, okay, which might be costly from an economic point of view. But currently, all of this determination of whether counties are in attainment or non-attainment of particulate matter standards is done using ground-based air quality monitors. And there are huge gaps in this network of air quality monitors in the country. I think something like 1/3 of counties don't have a single air quality monitor in it that is tied to enforcement of the Clean Air Act. So my colleagues, Alan Krupnick and Daniel Sullivan from RFF, they took MODIS aerosol optical depth derived measures of PM 2.5 and asked if we are to determine which counties are non-attainment and attainment based on those data, how do those determinations look like compared to the ground-based air quality monitor determinations? And what they found was that these yellow counties, so the black counties here were placed in non-attainment by EPA based on ground measures of air quality. And then the gray ones were placed in attainment status. And the yellow ones are counties that the satellite data revealed to actually be in non-attainment, although under the Clean Air Act they were determined to be in attainment. Okay, so these are counties that have been misclassified as being too clean. So, the additional step that my colleagues here took is, okay, well, in the hypothetical situation of these counties being regulated based on the satellite data, and so all these yellow counties actually being subject to additional controls on air pollution, if that actually happened, based on public health literature estimates on the relationship between pollution exposure and premature death, how many premature deaths could have been avoided? And they estimate over a 2-year period that would be about 5,600 premature deaths. And this is another thing that economists do. Now, market valuation, placing a dollar value on things that are hard to place dollar values on. The welfare gain using EPA standard non-market value procedures would be about $51 billion. So it's a big societal impact. So this is an example. The previous example, right, was sort of a program evaluation, impact evaluation type of study where, what's the impact of cells being treated by a well on agricultural land use, right? Here it's sort of the other way. You have this natural system, pollution observation. What's that effect of that on a human outcome, premature death? Okay, the last example I want to talk about is an airborne example. I thought it would be good to bring this one up. Basically, these authors got billing data for water consumption for a large section of the Phoenix metro area, so household level data, and tried to see so from the billing data, they were able to get water consumption rates. And what they found from the billing data is that neighbors tend to have these peer effects, that neighbors with lower water consumption tend to be neighbors with people who also have lower water consumption and vice versa. And using these airborne data, they were able to determine that it tends to be driven by landscaping choice, something very visual. So if I see my neighbor adopt dry landscaping, I'm more likely to adopt as well, and that reduces my water use. Okay, so they were able to get this, understand the mechanism behind what they observed in the billing data. I'll skip this because I'm running out of time. So there are uses like that for airborne data as well. So just to conclude with some questions for the group. I think this issue of matching the spatial and temporal scales of NEON data with socioeconomic data has come up several times already, and I think it is really the key challenge here. You might think about spatial and temporal scales tied to data on households and firms. This probably needs to come out of a tailored survey, proprietary data like billing data, or special access to government data. So this is, I think, a research challenge here. We've discussed census tracts. Those tend to be aggregations of several thousands of people. So to the extent that the research question is meaningful at that level of aggregation, it could be useful as well. One question that I have, right, is given that we might have to aggregate on the socioeconomic side, at what point then does aggregation on the NEON data side make it so that the NEON data are not as advantageous relative to potential substitutes of NEON data, right? So what are the attributes of NEON that, if we aggregate too much, we sort of lose those benefits? I think understanding that from a social scientist perspective can help us then think, a lot of the interesting socioeconomic questions to ask. One thing that came to mind is that, so again, in those regressions, right, you want the scales of the y and x-axis to match, right? But if the natural system outcome of concern has to do more with heterogeneity or variability of an outcome within the spatial unit of interest rather than sort of the mean level within that unit, then that might be an interesting question that could be tackled with fairly aggregate socioeconomic data, right? So for example, if this is a forest here and this is a forest there and you're all trees, right? This is a problem that I thought about for a while. So if there's a road going along these two forest areas and there's a lot of road salt application during the winter, and this forest here, the road right next to it, is a low salt area, which you sometimes see in the Northeast in particular, I think. What are the ecosystem benefits of those low salt areas, right? It might be just that there are more trees here than over here, in which case maybe you don't need something as detailed as neon to be able to find that statistical relationship. But if your hypothesis is that stand is going to be more diverse in terms of species composition or canopy height or whatever, relative to the one where maybe I'm getting things backwards. You get the point. The one that's been treated with a low salt area policy. Then the socioeconomic data are actually at the stand level, right? This one is 0 for a low salt area. This is 1 for a low salt area. But the ecological data are being exploited at the tree level or leaf level or whatever, right? And so if there are interesting hypotheses of that sort, then we might be able to link some of these very highly detailed neon data to much more aggregate socioeconomic data. I think I'm out of time, right? So I will just note that this issue of repeated observations can be extremely useful from a statistical perspective. We typically call it panel data. I hear time series being used here, but repeated observations of the same cross-section we call panel data. There's some issues with interpolation that can be problematic for economic research. Yeah, these are sort of general things. So, thanks.